Utilizing solar energy to our benefit is actually a very old concept. As far back as 700 BCE, solar energy was being used to start fires by focusing sunlight through a magnifying glass. The photovoltaic effect, which is the process of converting sunlight to electricity, was discovered in 1839 by French physicist Edmond Becquerel while he was experimenting with metal electrodes in a conducting solution. It wasn't until 1883, however, that American inventor Charles Fritz created the first working selenium solar cell. Fritz's invention was the precursor to all modern solar cells. A solar array is made up of anywhere from just a few to possibly hundreds of solar panels. Solar panels are then made up of dozens of smaller cells. Each of these cells is just like a sandwich and then it has two layers. These layers are usually made of silicon. The cells use a p-n junction. This means that the top layer has a negative charge and the bottom layer has a positive charge, which creates an electric field between the two layers. When photons from the sun hit the cell, they knock electrons free. These electrons are then pushed out of the silicon by the electric field and collected by metal plates on the side of the cell. From there, they can be used to power your car or phone just like any other form of electricity. As of now, solar panels are only about 40% efficient, meaning that the majority of sunlight is wasted. However, as technology inevitably advances, this number will surely go up, which means that solar power will become more viable as time goes on. The output of a single solar panel usually ranges between 200 to 400 watts. However, some may exceed 400 watts. To put that into perspective, a desktop computer setup uses about 400 watts. Monocrystalline solar cells are single crystalline cells that are identified by their black color. This type is made from pure silicon, making it the most efficient material for converting sunlight into electricity. However, these cells are the most expensive because of their purity and manufacturing process. Polycrystalline solar cells are made from multiple sources of silicon and are less efficient compared to monocrystalline cells. A different method is used to construct this cell, causing it to have edges and grains in the cell. Although this cell is less efficient than the monocrystalline cell, it is easier to produce. There are multiple ways that solar arrays are set up. Most residential solar arrays are placed on top of roofs and are stationary. This setup is most efficient when the sun is directly facing the panels. Solar farms are large solar arrays that are built to provide power on a larger scale. Some solar arrays are built with mechanisms that allow the panels to follow the movement of the sun for maximum efficiency. Another type of solar array is the solar power tower. This layout has a field of sun tracking mirrors called heliostats that reflect and concentrate the sunlight into a single tower. Solar energy batteries are installed as part of a solar panel system. Solar batteries have their own inverter which offers energy conversion. A solar battery would store the excess energy instead of sending it back to the grid. This stored energy might be drawn on cloudy days. In the modern day, solar panels have a very wide variety of uses. Often they are installed on roofs in order to generate free and clean electricity. In some cases, however, homeowners can sell the excess electricity back to the power grid for a nice bit of extra income. Solar panels are also extremely useful when it comes to supplying remote areas with energy. Their portability allows them to be used for anything like charging a phone while camping to supplying a town without a power grid with electricity. Generating electricity isn't the only household application that they have, however. Hot water solar panels are a type of solar panel that are able to supply a house or building with a considerable amount of hot water. Although typically these systems work in tandem with a more conventional water heater for when the solar heated water runs out or during the nighttime when sunlight is unavailable. Solar panels also have much more ambitious applications. On a space station, you probably don't want to use a combustion-based system to generate electricity. Obviously, lighting things on fire in space is not the smartest idea. Beyond that, however, using combustion to generate electricity requires fuel, and lots of it. Fuel would have to be constantly launched up and resupplied to the station. To circumvent this issue, we instead use solar energy. Not only is sunlight overly abundant in space, but solar panels are also fairly light and compact, which is a major plus when it comes to launching them into space. The same concept applies to rovers as well. One of the major disadvantages of solar power is the barrier to entry. In the US, it costs on average about $17,000 to have solar panels installed in your home. That number can get as low as $5,000 in some states due to tax breaks. For most people, that is still a very sizable investment. It can take anywhere from 7 to 20 years for solar panels to recoup their initial cost. This means that having solar panels installed in your home can be a risky investment, especially if you plan on moving homes in the next few decades. Another disadvantage of solar power is that it takes up a lot of space. Solar panels need to be unobscured from the sun in order to function. Often solar farms can take up space that would otherwise be used by livestock or agriculture. On the other hand, solar panels also have many advantages. For one, they have no moving parts that require little to no maintenance other than maybe an occasional sweep to keep them clear of leaves and dust. In addition to that, one of the biggest selling points of solar panels is that they produce precisely zero pollution in the process of converting sunlight to usable energy. It's reported that as much as 2/3 of the greenhouse gas pollution is due to so-called dirty energy. It would be very advantageous for us to use more renewable energy. A theoretical physicist, Freeman Dyson, created the concept of a Dyson sphere. The Dyson sphere is a megastructure that revolves around the sun and collects energy that radiates from it. Creating a Dyson sphere would take an enormous amount of time and resources, making it currently impossible to construct. The logistics behind an operation like this would have to cover the operations for mining, space transportation, and construction of machines. If a Dyson sphere is somehow constructed around the sun, then our energy needs would become non-existent. If we can harness 100% of the energy that the sun produces for just a second, at our current energy consumption, we could power the Earth for over 845,000 years. The construction of a rigid sphere around the sun is somewhat impractical, however. It would be constantly at risk of asteroid collisions, and it would start to drift in the sun with the slightest nudge. Not only that, but it would likely take more resources than we have in the entire solar system. A much more reasonable alternative would be more of a storm in the sphere. It consists of millions of satellites made of reflective material orbiting the sun and focusing its energy to central collecting points. While this method would produce considerably less energy than a sphere, it would still be more energy than we could ever hope to use.